Okay, part 2 of our video, we're looking at problem number 5. What transformations on the graph of f of x equal the cube root of x result in the graph of this? Alright, keep in mind our standard form of a transformation. If you have some function f of x and g of x is a transformation of that, and it's of the form a times f open parentheses b parentheses x plus c plus d. A and d are outside. They are y changes, and the y changes happen like you think they should. B and c are inside. They're x changes. And inside we're going to think inverse. The pluses think minuses. The multipliers think 1 over that multiplier. The added things, C and D are the adders. C and D, they are translations. They're shifts, either vertical or horizontal. A and B are multipliers. They are going to result in some kind of dilation, a stretch or a shrink. Vertical stretch, horizontal compression, those words. Stretch, compression. Alright, so in this case, the 1, it's inside. And it's an adder. Inside inverse, it's an exchange. So that plus 1 is 1 unit left. Inside inverse, you think it's minus. This 2 is outside. It's a y change. And it's a multiplier. It's a vertical stretch. Vertical y stretch by a factor of 2. Alright, so vertical stretch, yes. Horizontal shift, yes. Vertical shift, no. Reflection, no. We get a reflection when we multiply by -1. Mult by negative. That is, if A or B are negatives, that's when we get a reflection. Alright, omit number 6. I won't ask you to do one like this on the test. I'll briefly talk about the transformation part of this. If you the transformation they give us is of the parent f of x is equal to the square root of x. And if we graph that, it looks like this. So what you can see is this starting point here is 0, 0. And here it is -6, 0. So -6, that would be the h. That is, minus -6 is going to be plus 6. Again, inside inverse. This 0 would be the k. We could figure out the a if we need to, but you won't be asked to do one like that. Nor will I ask you to do one like number 7. We could, if we wanted to find a best fitting square root function, we could plot these 2 points in our calculator and do a regression to fit a square root function to it. Desmos will also do that. Number 8, what are the domain and range of g of x is equal to -1/2 the cube root of x plus 2 minus 4? Well, first thing observe are the transformation. This is going to be 2 to the left because of that plus 2. This minus 4 will shift it 4 down. So our starting point originally is 0, 0. The 2 to the left and 4 down will send us to -2, positive, -2, pardon me, -4. We're going to graph this here in a second and see. This -1/2 is a y change. It's a vertical compression and reflection. Vertical compression because it's multiplied by 1/2, and a reflection because of the negative. Let's go to Desmos and take a look at the picture. Y equals, we can do it to the 1/3 power, or First we need our negative 1/2, so negative 1 divided by 2 space. To get the cube root, we can go functions, miscellaneous, nth root, and our index is 3. Our radicand expression is x plus 2. That's going to shift it to the left 2. You notice how this turning point here went from 0, 0 to negative 2, 0. Now, getting outside, subtracting 4, it's going to move it down 4. There you can see it shifted it down 4. All right, we're asked to discuss the domain and range. Well, the domain is possible x values. You can see this thing goes infinitely to the right and the left. So the domain will be all reals. The range, while it might not look like it, it's also going to be all reals. This thing goes up without bound and down without bound. It looks like it's flattening out, but these numbers are going to get greater and greater and greater. As we put in larger and larger values for x, the cube root will be smaller than that, but it's still going to increase without bound. Same thing in this direction. So both the domain and range are all reals. D. All reals. All right, number 9. Write each expression in radical form. Simplify as possible. Okay, remember our definition of a rational exponent. A to the power of m over n is equal to the nth root of a to the m. And it doesn't matter if we do the powering or the rooting first. This is the same as the nth root of a taken to the m power. The denominator is the index. Kind of makes sense. The denominator is a divide, the index is the rooting. That seems to make sense. The numerator is the power, the exponent of our radicand. All right, so 3 to the 4 over 3 could be written as the third root of 3 to the 4th, which is the same as the third root of 3 taken to the 4. This one makes a little more sense here because we can evaluate 3 to the 4th power. 3 to the 4th power is 81. So we would further write this. We could write it as the third root of 81. Any of these expressions would be satisfactory. B, in this case, we're going to employ our power rule of exponents. A power to a power we multiply. 81 has the implied power of 1. So what we have here is 81 to the 1/2. V squared to the 1/2 becomes V to the first. I've simply multiplied the 1/2 by both those exponents. Well, V to the first, that's as simple as it can be. 81 to the 1/2, that means the square root of 81. That's 9. So this is 9V. Remember, the 1/2 power is simply the square root. This is saying the square root of 81V squared. Square root of 81 is 9. Square root of V squared is V. All right, again, we have the 1/2 power. The 1/2 power is the square root. So this is the same as saying the square root of 11x. That is what B says. C is not right because it didn't take the square root of the x. D is not right. It didn't take the square root of 11. A is completely jacked up. They just changed the 0.5 to 2. That's no good. All right. 13. Write each expression with rational exponents. So here we're going this way with it. All right. I mean, we're going from the radical to the rational. So the cube root is the same as the 1/3 power. So I can write this as 6m squared to the 1/3 power. I could use the power rule and multiply. This would be 6 to the 1/3. M to the 2/3. Either of these expressions would be satisfactory. This is the 4th root of 48n. I could write this as 48n to the 1/4, which is equivalent to 48 to the 1/4, n to the 1/4. Noting that both of these have an implied 1 exponent. The power rule says power times power multiply. Multiplying 1/4 times 1 yields both of those exponents. 14. Which expression is equivalent to? Well, let's first go by changing my square root into a 1/2 power. So the numerator becomes x y to the third to the 1/2. The denominator is xy. I'm going to write it as 1 first power. In the numerator, using my power rule of exponents, I multiply. 1 times 1/2 is 1/2. 3 times 1/2 is 3 over 2, also called 1.5. I can simply write it as 1.5. 3 times 1/2 is 1.5. Half of 3 is 1.5. Over x to the first, y to the first. Now I'm going to use the quotient rule. The quotient rule says when dividing we subtract exponents. So 1/2 minus 1 is a negative 1/2. 1.5 minus 1 is a positive 1/2. Lastly, the negative exponent rule says anything to a negative power, I can take the reciprocal of it. That is, this becomes, you can just think of moving it from one side of the fraction to the other. X to the negative 1/2 in the numerator is x to the positive 1/2 in the denominator. So we have y to the 1/2 over x to the 1/2. And lastly, the 1/2 power is the square root. So I could simply write this as the square root of y over x. Lots of different ways we can express that. They are showing A. That'll conclude this video. I'll put the rest in a part 3.